All right, wait for it. It's always a long minute. It's always a
15
long
seconds.
minute. I don't have a second hand, so I'm just waiting for that minute to bang. And it's usually the longest minute of the day. There we go. All right, it is 2 hours UTC. And once again, it is time for Astronomy Daily Live. So this is just a casual, fun get-together of friends every single day to sort of sit around in a virtual circle and think and talk astronomy for an hour or so. It usually goes a little bit more than that. Sometimes it's a little bit less. Sometimes it's a little bit more. It varies. It varies. And on the panel, Bobby, what's happening?
Yeah!
It's been one of those days, huh?
uh, it's tomorrow is going to be another check day for Social Security, and we're going to do something big and stuff.
Very cool. Very cool. Yeah, everything's just humming along here too. Yeah. Nothing incredibly crazily exciting, but yeah, just humming along. So all is well. So hope everybody's doing well out there.
I wish we got somebody in the chat. What's up, Tim?
Tim, hey, nice to see you. Hey, what do you think of the new camera? Yeah, do you like that, Tim? All right, very cool. Yep, all is really well. It's now. So are you up early, or are you up late, or are you up early? That's the question.
Yeah, that's
Or
a good
maybe,
question.
yeah, or maybe both. Maybe both. Who knows?
And here's our water.
There's Tawahinta in the house. Yeah, it's about time. I decided, when I got a sustained 100 subscribers, that I'd get a new camera, and this one actually, will it focus on my hand? Thought it did when I tried it just a second ago. There it goes. Anyway, yeah, it's a Logitech C615, and the most important thing, the most important thing is, I'm noticing that my live stream is sort of stalling here. Uh, is that it's a wider field, right? I mean, my camera before, was like this, right? Just like this little thing here. So it's a wider field of view. I also have control, right? So I can change the the the, the exposure time, basically the frame rate. I can change the gain. I can change the brightness and contrast, the amount of color, right? I mean, if I wanted to go black and white, I could go black and white, and that might be interesting.
Crazy. I think they have crazy days today too. Got Tim Robinson with a garden fire, and Uncle Bill is working on a lake problem.
Helping a guy with HDMI AMD Linux. Oh, that's uh, an interesting combination of problems. Yeah, Tim, I had ordered a I, I forget what it was now, and uh, it's the little tracking thing said that it was delivered, and it never was. So I got with eBay on that, and they reviewed it and said, well, the tracking says it was delivered, so too bad. So yeah, I just went to the store and got one. So sometimes
Just
you
like
just
the
got.
girl took up more money for a prom dress because she got one online. Everything was out of bounds.
Yeah, yeah, yeah. So this will work fine. And as I said, I like the wider field, because I can, I can move around a little bit more, right? With the other one, I, I was having to sort of stay in the frame and all of that, and you never saw me, waving my arms around or anything else, because I do that, right? It's like I wave my arms around and I talk to my post office, and they were not really very responsive. I probably should have followed up a little bit, but I did a little bit of diligence, and it's sort of like, well, oh well, that's that's how it goes. I guess, as I was saying yesterday, I think if the dollar amounts were different, I might put up a little bit more
I
uh,
had a refund with,
of a.
with my missing money order.
Yeah, yeah. I think the circumstances were, basically my word against the United States Postal Service, and I guess they're a little bit
Now,
more
somebody
trustworthy.
may have like took the package without you knowing.
Yeah, I'm not sure, and not sure exactly what
If you
happened.
was like that by yourself and you had neighbors, they would have watched it for you.
Yeah, 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 and I mean, I guess I do have a couple of neighbors. They're a little far out, but in terms of distance, um, but yeah, no word there, and it's really really hard to mix up houses out here because there's so few of them. So it's sort of like this is sort of the only one around. So yeah, I'm not going to sweat it. It's not a big deal. As I said, I think if the dollar amounts were different, I probably would squeal a little more loudly. But I checked it out, and I sort of followed the path, and it just led to a dead end. So it's like, let it go. That's millions and millions and millions of kilometers away now. So I'm just, man, he received an empty envelope, huh?
That was that
Yeah.
Christmas card. You forgot that Christmas card Sam made for Jill, and he never got it.
Oh wow. Yeah. Well, you know how those Canadians are. They just don't trust anybody, especially if it's coming from an other um, Anglo-Saxon country, right? I mean, then the Canadians are like, oh, we know we know all about you.
I guess Anglican, Saxon, and Acadian don't even mix.
Hmm. Very cool. All right. Well, what I thought I would do is continue looking at the events for August. But before I do that, as I said, I like this live stream to sort of be us sort of going along investigating things. And one of the things that I try to do every single day is look at the new papers over on archive.org, and didn't get a chance to do that today. So I thought, let's all go in and just take a look,
And I
see
have to
what's
say
up.
hello to Patrick.
Hey there, Patrick. You're here early. That's me, or if that's somewhere along the way, or if it's you, I doubt it's you. So it's probably me. It's this poor laptop trying really really hard to uh, you know do what I'm asking it to do. I'm probably pushing it a little bit too too hard. And you know what,
I have to like
Patrick,
keep
that's a good
refreshing
point.
as well.
I'm gonna turn my bit rate down a little bit and see if that helps. Whoop, I'll set it to medium, and we'll see if that helps a little bit. Hey there, Tom. Nice to see you also. Very, very cool. So yeah, let me know if this is any better. I've turned it down. It was set to high. Now I've set it to medium. So see if that makes any kind of improvement. So yeah, as I said, I think I'll do first is go over to archive.org and let's take a look. I haven't looked at today's papers yet. So archive.org is this awesome site, and as you can see, it's ARXIV. This is a Greek letter chi, so it's archive, right? .org, and this is just uh, more or less the latest and greatest bleeding edge papers, not only um, to do with astronomy and astrophysics, but also uh, all of physics and all of mathematics and computer science and biology and finance and stats, electrical engineering, system science, economics. So yeah, let's look at the latest economic papers, right? These are scientific papers. Uh, and oh yeah, there aren't very many. There's just one new one today. But yeah, if you're interested in any of these topics at all, these these papers they come out before they're published. So you're seeing them. You're seeing them. Even before they sort of hit the newsstands, right? Um, so it's very, very cool if you like to keep up on those kinds of things, and uh, rightly so. Rightly so. Um, Astrophysics is the top one, so they've done well. Now, and of course, it's just because it's alphabetical order, but I want to say that it's the top one because it's the best one. So ones. So these papers they come out. Um, uh, Chat window drops below the screen for some reason. I don't know, Tim. Maybe all your computers are tired. It's too early. So these papers they come out every single weekday, so Monday through Friday, and they usually come out around 1 hour UTC or so. Sometimes it's a little bit before that. Sometimes it's a little bit after it, but usually by 1 hour UTC, you can hit the new button there, and you will get the new papers for the current day, right? And of course, the current day is the 3rd of August, 2018. It is 2:14 UTC. So where Tim is, right, it's 3:14. It's pie time. It's pie time in England. So, have some pie. Enjoy your minute of pie over there, Tim. It's the true pie, right? It's not the 3:14 in the afternoon thing. That's not really 3:14. That's 15:14. So this is your only true pie. All right, so let's take a look at these. Yeah, we're good over here. Tim, hope your lady's doing all right. Haven't seen any live streams or videos from you recently. Hey there, Space TV. Nice to see you also. Look, Space TV, you're coming in, and I'm actually here and operating. Maybe a little glitchy, but definitely here. So glad that you could come in. Yes, let's let's take a moment and enjoy our drinks and or consumables. Cheers. I've got the regular hydrogen hydroxide here, HOH, and it's exceptionally nice tonight. It's a new batch, so new batches are always really really good. All right, so come along with me, friends. We're going to take a look at the latest and greatest in astronomical research and observations and all that. Now, what I do is I sort of look at the titles, right? I look at the titles and I see if there's anything that sort of catches my interest, either because I know something about it already and want to find out more, or if it's something new that I've never heard of and it's like, what is this? And then if there's a title that catches my eye, then I will sort of skim the abstract. This is called an abstract. It's like a um, executive summary of the paper. Um, and that gives you a good idea as to what's uh, um, going on in the paper itself. So let's take a look here. Clouds in arms. Clouds in arms. So we use astrometry and broadband photometry from DR2 of Gaia to map out low surface brightness features in the stellar density distribution around the large and small Magellanic Clouds. The LMC appears to have grown too thin and long stellar streams in its northern and southern regions. Highly alarms. Oh, cool. Okay. We're talking about the possible spiral arms in as being part of the large Magellanic Cloud. That's very very cool. Yeah, I think that's sort of a very cool. Yeah, I think that's sort of a newish thing Gaia has turned up. Is this interesting motion that at least the Large Magellanic Cloud has. So yeah, pretty interesting. They're not interesting enough to really dive into though, but very very cool. Fuzzy dark matter. Let's see. Horizontal branch modeling, disruption of a planet spiraling into its host star. Process leading deformation and destruction of planets spiraling into the convective element of their host stars is described. The planet is compressed by the ram pressure and deformed into a flattened shape for which a quantitative model is developed. Huh, pretty interesting. Huh, pretty interesting. Should we, I just like to, oh, is my internet locking up again? Oh, man.
I think you're good here, Gothic.
Okay, let me reload my my smartphone because Tim is saying that I've locked up, but yeah, I think I'm all right. So okay, all right, all right. I'm gonna keep it going. All right, so let's just sort of these kinds of things. Let's just sort of look at the pictures and see what they're up to. Right, this is a total model, right? So This guy's in China and this guy's in Germany. Very cool. Disruption of a planet spiraling into its host star. Let's see. Probably gives some kind of where they're a little bit of math there. It's not too bad. They show the different stages, maybe. I don't know. Looks like all the pictures are at the end. Oh, here we go. Distortion of a planet ram pressure. Okay, yeah, that makes sense, right? Yeah, I know. I'm just flying through all this stuff. A 20 Earth mass iron planet orbiting a 1 solar mass pre-main sequence star, age 3.8 million years. Million years? Okay. Variations in the distance from the planet to center of the star. Okay. Various, not quite sure what that is. And I don't think I'm going to linger on this too much. I just sort of wanted to see what a planet is going to do as it spirals into a star. They should make a movie, you know? Fragmentation process. Great. Let's see. The goal of the calculations was to quantify the processes contributing to or delaying the destruction of planets spiraling into their host star. The high density of a planet compared to conditions in the great part of the stellar envelope allow it to survive to some depth into the envelope. That's pretty cool. So they did it for iron and gas planets. Pretty cool. Nice. For some combinations of mass and composition, a planet can survive its path through the entire convective envelope, disrupting finally in the radiative interior. Don't really give any numbers here. We probably have to look at the data in order to really do it. But we're just skimming archive here. I can attest, Patrick, that an 8-inch is absolutely not that big at all. You can see. I'm going to go back to sharing my screen here really quick. You can see as soon as this pops up. Well, there about when moving a scope around is putting it down. Right, got to make sure that you don't bang it on the ground. No, it's just Chrome. I've got so many instances of Chrome, though. It's really strange. I'm not quite sure why I have so many. I'm going to try something. Let me try something here. I'm just wondering.
Oh, now you're back.
Good. I'm just wondering. This is not what I necessarily want to do, but I'm doing it anyway. I've got like a bunch of these tabs that I don't think are actually open, but I'm wondering if they start up. It's the only reason why I can think that I've got like a cajillion of these things. One window in Chrome shows 11 instances. Yeah. I can believe that, Tim. I can believe it, but yeah, it looks like I'm still spinning. Dang. Trying to get rid of all these.
Now you're spinning again.
Yeah, I'm spinning again. Arr. It's probably just too warm in here too. Poor machine has to work. You know, the fan on thing is just screaming. So it's working hard. I noticed that, Tim. I'm working on it. This is not a computer show. This is an astronomy show. Wow, there's a lot of these. How many chromes do I have? See, I've got a lot more than 11 chromes. I've got probably 5 running. Not seeing really a lot of.
I know there's like a lot of people got 32 gigs of RAM or 16 gigs of RAM. I have 4 gigs of RAM with my Chromebook and it still runs like a son of a gun.
Yeah, I'm not sure what I've got in this thing, but I want to say it's probably about 4 or so. So, yeah, but it looks like I'm just spinning on my smartphone.
Yeah, it just runs like if you got more RAM and stuff.
Yeah, well, getting a new machine would be the thing to do. Or I can try to. I don't. I is there a Chrome for Linux, or is that just a Windows thing?
You're talking about Google Chrome for Linux?
Yeah.
Yeah, there's a Google Chrome for Linux.
Is there? Maybe I should
Yeah.
try. Maybe I should try that. Um, because yeah, this is not acceptable. Not acceptable at
Yeah,
all.
you should like try putting like Ubuntu or something, and then put Chrome on it.
Yeah, well, I've got Fedora on 3 machines here, so that should do. And yeah, and that's actually what I'm running on this Linux machine here. Is Fedora. I've just never run Chrome on it. Okay, hold on a sec. Yeah, I'm just spinning over here.
Yeah, the download page for Chrome is supposed to be the same thing if you was downloading for Windows or Mac.
Okay, yeah, I'll have to look for it. All right, well, Tim,
Good night,
if you can hear me, Tim, have a good one.
and never mind.
It's trying. Yeah, wow.
I don't know, but I think you're just spinning around again.
Yeah, I think I am too. Let me kill a couple of these windows. Can I kill that one? I can kill that one. Let's see if that helps. I think that knocked him down a little bit. Okay, there we go. I can see my video on my smartphone. It looks like it's kind of choppy, but it also looks like it's there. So, okay. Uncle Bill, the poor laptop is having to work really hard, and it's hot. And it's hot. So, all right, I think I'm going to keep going. We'll just do this one screen at a time. No problem. No problem. So I'm going to share my screen again. Dun, 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 dun. Go to infinity. Woo! There's Bobby at infinity. Look at him way back there. Yeah. All right. Enough of that. Let's try to look at a few more of these archive because I want to get to. No, Uncle Bill, I do not blow out any of the cat hair at all. Should I? Should I do that? Huh. Daniel, what am I going to call today's episode? Question about, the big freeze in the middle of the summer. All right, let's keep moving here. It looks like we're sort of back. I knocked out a couple of Chrome windows, and I think we might be back. So where were we here?
You should definitely try to get some to try.
Yeah, well, I think those are just bookmarks, though. I've just got one tab open now, and that is this one. So, right, clouds and arms, disruption of planet. Okay, so we just look at that. There we go. Let's see. Core fragmentation, cold molecular light gas. So these are interesting stars. We'll have to investigate those at some point. They're really, really, really big and bright. Hot. So the second planet with an Earth-like composition, massively accreting cluster, and I assume that's Abell 2029. That's a galaxy cluster. We explored the structure of galaxy cluster Abell 2029 and its surroundings based on intensive spectroscopy along with X-ray and weak lensing observations. Abell 2029, huh? A big freeze. Yeah, you know what, Patrick? I hadn't thought of that. That's an interesting theory. It's an interesting theory. I'm gonna have to keep an eye. Gonna have to keep an eye on him, I guess.
How could I be doing a DDoS?
I just got to keep an eye on you. That's all. Let's see. ST, of course, is the Large Synoptic Survey Telescope that is currently being built. That's going to be crazy when that's operational. Oh, man. We're talking about between 1 and 10 million alerts every single day. We're going to need a lot more astronomers. Any volunteers? Let's see, 2017 upgrade to Bicep 3. Not seeing anything really interesting, but as you can see, at least in the astronomy section, there's usually 20 or 30 new papers every day, and it covers everything, right? Covers the whole spectrum, pun intended, of astronomy, from instrumentation to models to observations, all of it. Super malt. The physical and chemical properties of massive and dense clumps. I don't know if I'd want to put that on my resume or not, you know, that I studied clumps. I don't know. More so planets. Everybody's very excited about extrasolar planets these days, and I'm not doubting at all that we're uh, actually seeing planets. I'm just not sure if we're seeing as many as we think we're seeing. But I haven't read any of the papers on, you know, they accounted for false positives and all of that. So I'm not speaking there with any knowledge whatsoever to the gut reaction. Good. Glad. I'm glad everything looks steady. I guess, yeah, I had 3 Chrome tabs up, and I got rid of 2, and so now I just have this one that you're looking at now. And I guess that sort of untaxed the system. So let's see. Adaptive coronagraphy. Excitation of a primordial cold asteroid belt. Double dust envelopes of our corona borealis stars. Huh, double dust envelopes, huh? Kind of cool. Study of extended cold dust envelopes surrounding our corona borealis stars began with the discovery by IRAS. IRAS was a infrared telescope back in the 80s. Was it the 80s? Yeah, it's been a while. So RCB stars are carbon-rich supergiants characterized by their extreme hydrogen deficiency. So not much hydrogen seen in the spectra, at least. Could be elsewhere in the star, right? You know, deeper in, or, but you know, maybe not a lot. Okay, and they're irregular and spectacular declines in brightness up to 9 magnitudes. So that's, every magnitude is a factor of 2.5. So grab my handy calculator, always at arm's reach. And if I do 2.5 to the 9th, that is a factor of 3,814. So wow, that's pretty amazing. You know, that's over 3 orders of magnitude difference in brightness. So pretty amazing. Herschel space. Oh, what? I messed that up pretty good. There we go. These data allowed the assembly of the most comprehensive spectral energy distributions for these stars with multi-wavelength data from the ultraviolet to the sub-millimeter. That's a pretty broad range. Yeah, pretty cool. Laboratory experiments of agglomeration of particles in a granular stream. Inelastic collisions occurring among regolithic particles, such as those in the ejecta curtain from a crater, may cause clustering or agglomeration of particles and thus produce discrete patterns of ejecta deposits around a crater. Hey, and that's exactly what they're seeing. So yeah, they're trying to explain why the ejecta around craters isn't uniform, right? There's like these rays. So that's kind of cool. Cool. cosmic strings, near infrared spectroscopy. Spectroscopy is the bomb. You can all there in the spectrum. It's pretty nice. Let's see. Not being anything incredibly exciting. Quite a few papers though. To polarization monitoring. It's kind of nice. Another coronagraph. Global non-adaptive optics. 3D printed broadband millimeter wave absorber. Measuring the star formation rate, gravitational waves from binary black stars, black holes. Huh. That's a pretty far out paper. RB, fast radio bursts. Fast radio bursts are completely nobody knows what they are yet. But we'll get to the bottom of it. There's the last one. I really didn't think incredibly interesting there. Lots of papers though. Holy moly. Quite a few. All right, well let's I'd like to do that anyway, and it's kind of fun sharing it with all of you too. So let's go over to Cloudy Nights and try to finish up the August 2018 events. I think we with the Perseids that are going to be going on somewhere, they start around the 10th or 11th, and they'll go to the 14th or the 15th or so. There's a website that I think I put in the Discord before. I'm gonna have to find it. It's a site that shows you the hourly rate of meteor showers pretty much live. They keep it updated, and I'm sure if they don't already have it up already, they'll be putting up the Perseid chart pretty soon. Because that's we're probably going to be starting to see some Perseids even now, and it'll go through the entire month. But we definitely go through the thickest part around the 13th. So
it'd be great if there were some live feeds.
Yeah, I thought about that, and the only that I think I would have is that I'm not sure. One, I don't have like an all sky camera, so the field of view, even with my smartphone. Oh, I think am I spinning?
You're good here.
Am I? Okay. Okay. My smartphone has a pretty wide field of view. I don't know if it could really pick anything up. I guess probably what I'll have to do is I'll have to experiment, right? I'll have to go out one night between now and like the 13th, and point the thing up in the sky, press the video record, and see what it shows. I have my doubts, though. But yeah, that might be fun. I mean, it would be I'd probably want to do it. I'd probably want to start around maybe like 10 hours UTC or maybe 9 hours UTC. So for me, that's pretty early in the morning. not a problem though. Being an astronomer, you get used to those kinds of things, so it's not a big deal. But yeah, I guess I'd want to know that we'd actually be able to see things. And I have my doubts about that. So yeah, I think it's a good idea. I will try to investigate that. I mean, I've got to have some clear skies here too. And August is usually, we're still in the monsoons, so usually I've got clouds. So, all right, well, let's see. On the 14th, we have another sort of nearby pass of the moon and Venus. That is definitely a photographic event. So anytime that day, right? This is the closest approach is at 18 hours on the 14th. But I would say anywhere plus or minus 12 hours of that, you're probably good. So I am definitely going to look at that on my evening of the 14th, maybe even the 13th, or maybe even the 15th as well. It's just, sort of a close approach. That's not incredibly close. Okay, so at least according to this, Venus is going to be half phase, half illuminated on the 15th. And we were looking at Venus the other night. It still looked pretty gibbous to me, but yeah, it was close to half. So I wouldn't be too surprised if that's about right. Not very close to Spica, but sort of. So Mars has reached its greatest declination south. That's nice. Here's another libration reference. I really need to figure out exactly what this number means. Gotta figure that out. This is sort of the month of Galilean satellite shadow transits, doubles. So this one's happening a couple hours before Astronomy Daily Live. Let's see, the moon is pretty close to Jupiter. That's cool. And also on the 17th at 7 hours UTC, Venus is furthest away from the sun that it is going to get. So 45.9 degrees, that's pretty far. That's pretty far, right? That's going to take about 3 hours after sunset for Venus to set. So that's not too bad. It's about 15 degrees per hour. So yeah, that's cool. So from now on, well, after the 17th, Venus will appear to be getting closer and closer to the sun. And it's actually going to be on our side of the sun then too. First quarter moon on the 18th. Mercury stationary right ascension. The lunar X. Another interesting little feature on the moon. Cool. It's Mercury stationary. 19th. Moon's going. That's not really even close, but I suppose it's a little bit close. Another double shadow transit. So Mars pretty much below the ecliptic plane, about as far as it's going to get, it looks like. That's right when Astronomy Daily starts, so maybe we'll try to remember that. Moon is pretty close to Saturn, to 1 degrees. That's getting a little bit close. That's happening on the 21st. We've got another transit on the 22nd. Wow. So then on the 23rd, Moon's at apogee. That's the furthest it's going to be from us, 405,000 kilometers. There's another transit, double shadow transit. And the Moon is at the descending node. That means it's now moving south, or lower declination. It's crossed the celestial equator going south. Full moon on the 26th at 11:56. Mercury is at greatest western elongation, so it's a morning star right now at 21 hours. So yeah, towards the end of the month, going to have to get up a little bit early before the sunrise and take a look at Mercury. I've definitely looked at Mercury through a telescope, for sure. It's been a while though. It's been a while. Let's see. Moon and Neptune are sort of close. Mars stationary in longitude. Another double shadow transit. Mercury's at its ascending node, so that means that it is crossing. Through the ecliptic. So it's crossing the ecliptic plane, heading north. And on the 31st, again, there's a double shadow transit. So that's happened a lot. That's pretty amazing. Nice to catch one of those. Let's see. This one's happening at 5:12. That's a little late. Ooh, look at this one though. 2:35. I think these things last for, I want to say about an hour or so, maybe even more. So 2:35 to 3:35 UTC. That sounds like a pretty interesting possibility. I don't know if we could see those shadows or not. I don't know. The seeing would have to be pretty in order to do that. So I'm not sure. And then along with the calendar, he throws in all of this other stuff, right? Just tons and tons and tons of, historical information, people and events. He's got a special place here for the Perseids. So that's very, very cool. Sun is located in Cancer on the 5th, goes into Leo on the 10th. It'll be nice to see some pictures of the eclipse. And then, just a bunch of numbers. Where all the planets are. Cool. Still listing Pluto as a planet. I'll have to do my Pluto rant again here pretty soon, since it's been a little while. The story hasn't changed, but I'm not going to do it today. So Mars is getting further and further away from us. Apparent size is getting a little smaller, right? And it's getting a little it's wait a minute. During August, Mars decreases angular size and in brightness from -2.8 to -2.1. That's brighter. Oh, no, no, no. It's negative. It's negative. So, okay, yeah. So, yeah, that just didn't make sense when I first looked at it. But yeah, it's getting fainter because obviously it's moving away from us too. So it looks smaller and it looks fainter in time, of course. Jupiter. So Jupiter's getting a little fainter too and a little bit smaller too because of course we're moving away from it as well. When Jupiter is in conjunction with the sun, we will be as far away from it as we will get, and that's not going to happen for at least a couple more months. Saturn, Uranus, Pluto, got some comets. We should do a little comet update. Let's do a comet update. There's a sort of the one that I found the most easiest was actually over on Heavens Above. So let's just see what comets are up, because there was that one comet that was doing some kind of new outburst, and I haven't heard anything more about that. Don't remember which one it was. I want to say it's this one, S3, but that looks pretty faint. So yeah, pretty faint comets. There's only a few out there, it looks like, and they're pretty faint. Ninth magnitude is definitely going to be pretty faint, even in a telescope. With an 8-inch, you definitely be able to see it, but it's going to be a faint little smudge. It's going to look like a galaxy. Faint little smudge. And Circinus, oh, okay, that's southern hemisphere too, I think. So I ain't gonna see it. Oh yeah, yeah. At least from my approximate location, it's only gonna be like half above the horizon, so I ain't seeing that. Oh well. All right, well, cool. So we got through the whole August events. I'm
What is
gonna
the smallest telescope you need to see Jupiter's light?
say that again, Bobby.
What is the smallest telescope you need to see Jupiter?